You can view all the lectures online, the recordings. There'll be a playlist I'll be creating as the semester goes on. So this is COP 3402 System Software. My name is Brent Pappas. I'll be your instructor for the semester. I'm glad to see you all. Oops. So before we begin, I want to tell you a little bit about me. As you can see, I'm pretty young, younger than a lot of the other professors here at UCF. It's because I'm not a professor, actually. I'm a graduate teaching associate, instructor of record for this course. So I am going for my PhD under Dr. Paul Gazzillo. This is my 6th year in the program. My research is really at the intersection of security and software engineering. That's sort of the high-level overview. If you're interested to know more about what I work on, you can ask me after class or during office hours. Also, I'll probably be sprinkling in mentions of my research and research in the broader lab that I'm a part of throughout the semester as part of the course, just mentioning things maybe to spark your interest in research potentially. I've taught this course twice before, so in the spring of 2026 and last summer 2026. I've been trying to improve the course, gradually making it my own. This was originally my advisor's whole curriculum. The slides were his. I've been modifying them, trying to respond to student feedback to make them as good as they can be. I'm really excited for the last half of the semester. I've revised the whole final project, responding to a lot of student feedback. I'll get to that when we get to that, but yeah, I'm really excited to be teaching again this semester. One fun fact about me is that I really enjoy reading, so I'll change tabs here. I have a list here of just some of my favorite books that I've read. If you want to mine my personality for some reason, I have a whole spreadsheet of all the books I've ever read that I can remember reading. So yeah, if you like reading, want to nerd out about books or literature or anything, just come talk to me after class. I have lots of recommendations. And I'm open to more recommendations, though my time is somewhat limited lately. Okay, let's go back to the slides. So enough about me, more about this course. What is the actual goal of this course? It's system software. That seems like sort of a nebulous term. Our goals are to both learn to use and develop system software. And what exactly is system software? Well, the definition that my advisor and I have been using for the past several years teaching this course has been to define system software as the bridge between the kernel and its applications. And I see someone's taking a photo. Just a heads up, all these notes are available online. We'll get to that when we get to the syllabus overview at the end of this lecture. All the slides you see are generated from the same set of notes that are available online. So I don't distribute these slides themselves because the same content is available online for you and more. The speaker notes are also available online on the course website. We'll get to that when we get to the syllabus overview. So anyway, back to system software. If we look at this sort of software and hardware stack here, where user applications like YouTube, a web browser, a video editing software, a video game, these are at the top, and you have your hardware at the bottom. These are like storage mediums, USBs, USB drives, mice, keyboards, things like that. System software and the kernel are sort of in between, and as we're going to learn throughout the semester, the kernel is what interacts directly with the hardware to let you store data to a disk, read data from a disk, things like that. And system software is sort of the layer on top of that interacts with this intermediate software, the kernel, which is tied to your operating system, in order to enable you to write software like YouTube or a video game or a web browser, things like that. Now I think people learn best by example, so let me give you some examples of what system software would be. So you all should have taken Intro to C. I think it was a prereq for this course, so you should be familiar with standard I/O, the header, malloc, generally the glibc implementation of the C standard library. You should be familiar with these things. These are examples of system software, tools that programmers use but that end users of software don't typically interact with. So speaking of which, compiler tool chains, so like GCC, linkers, we'll learn more about what those are later this semester. These are, again, tools that programmers use, programmer-facing tools, not end-user tools. Those are examples of system software, tools that we develop as programmers to make our lives easier so that we can write software that end users, consumers of software like to use. And we're also going to be learning about Git and Make. These are other examples of system software, programming environments, ancillary tools for software development. I guess by a show of hands, who has used Git before? All right, that's good. Figure. Who has used make before? Okay, fewer people. That always is the case. We'll be learning more about both of these tools this semester. Just a heads up, we're not going to be using GitHub. We're just going to be using Git. We are going to be pushing and pulling data to and from remote repositories. We're not going to be using GitHub. I'll be plugging this course throughout the semester, but if you want to learn more about GitHub, you should take software engineering with Dr. Kevin Moran. He's a newer faculty member here at UCF who's great. His course is really interesting if you want to learn more about real-world software development. This will be sort of an introduction to some of the concepts you would learn in that course. So what are some reasons to study system software? The first would be to know your tools. So who knows Isaac Newton? Or I guess who doesn't know Isaac Newton? Can anyone tell me what Isaac Newton is known for?
Gravity.
Gravity, right? So he studied physics. He was also an astronomer. He was very much into astronomy. And when he was alive, you couldn't just go to a store and buy astronomical lenses, telescopes, and you couldn't place an order for them. You couldn't give anybody a specification and have them just generate or create these telescopes for you. You need to make the lenses for these telescopes yourself. And so Isaac Newton would painstakingly grind these glass lenses in order to create his telescopes for astronomy. And while doing this, he took copious notes. You can see like this image here of diagrams, all the writing. There might even be some formulas in here, I'm not sure. And that's to say, we kind of have the same opportunity here as software developers to do the same approach of making our own tools, of learning our tools really well, taking copious notes on how they're developed and how they work, and adapting them to our purposes. Another reason you should learn these system software tools is that it makes you a better programmer overall. So we have here a chart from IEEE. This is a reputable source for computing research. The chart's kind of small on the screen, but Python, Java are the two top languages, but in third and fourth place are C++ and C. C is ubiquitous in software development. Like a lot of the software you use, Windows, Mac OS, Mozilla Firefox, Google Chrome, Android, these things are all written in C or C++, and so really C kind of forms the bedrock of our digital society. So by learning how to use C, you can make yourself a more appealing candidate on the job market when you're probably going to be interacting with some of these tools. And just be a better programmer overall, I would say. And another reason is I really think programming is very fun. I'm very passionate about it. I don't know, has anyone heard of Fred Brooks before? Anybody? I'm kind of surprised. So, yeah, you have? Okay, what is Fred Brooks known for?
Well, I haven't actually seen what he's known for, but I've heard the name before.
Do you remember anything about how you heard of his name, or?
I just heard it because I also looked at from the projects I've seen him be quoted for this exact same.
Yes, yes.
It's great to find that.
So, Fred Brooks is a famous computer scientist, software engineer. He is perhaps best known for his book, The Mythical Man Month, in which he talks about experiences in real-world software engineering and managing large software engineering projects, and how adding more people to a project does not often make that project get finished faster. And he has this great quote. I managed to find this picture of him smiling and laughing, which I really liked. The programmer, like the poet, works only slightly removed from pure thought stuff. He builds his castles in the air, from air, creating by, little bit here, there we go, creating by exertion of the imagination. So programming is uniquely situated in that, unlike other engineering disciplines, we don't have to go to Home Depot or Lowe's and buy a bunch of materials and actually create what we're engineering. We can just write code and see it work right in front of us. And it's kind of like poetry. It's like an art form in that we can be very creative and imaginative with what we make. But unlike other art forms, we can actually see that thing run right in front of us. We can interact with it. You can make an animation, make a video game, whatever, and interact with it immediately. And to me, that's very exciting. It's one reason that I really enjoy programming, because of how interactive and also creative it is. All right, some other fun quotes that I bring up typically in this first lecture. A poor workman blames his tools. So this is just an old proverb. Again, when you're working in system software, what I want to try and instill in you throughout this course is the mindset of us being able to modify our tools if they don't suit our purposes, or us being able to modify how the tools work, it's really, because we're programmers, we have the ability to modify all the tools we're working with, especially since they're open source. So if the tool doesn't work, we shouldn't just blame the tool and leave it at that. The onus is really on us to modify, enhance, or just use a different tool altogether if the tool we're currently using does not suit our purposes. Related to this is a quote that my advisor had thought that he had originally came up with. Tools are made for the man, not man for tools. So again, you shouldn't be beholden to whatever software or program you're using. Remember that it's ultimately for you to serve a purpose. And we're going to be seeing that a lot this semester with all the different tools that we're going to be interacting with. And you can see here's the original quote. Yeah, not from my advisor, unfortunately for him. It was actually made independently by two different people. And then a last funny quote, my advisor had put this here. Don't use your right hands, use a tool. I feel like anybody who has an older relative has probably told them something along this line before. Yeah, work smart, not hard, something to that effect. So as I said before, there were really two key goals for this course. Learn to use system software and learn to develop system software. So first I'm actually going to divide the semester up into two halves, and we're going to be really achieving both of these goals throughout both halves of that semester, but I'll get into that in a second. So for goal one, learning to use system software, we're going to be using the command line a lot. So the very next lecture, I'm going to open up the terminal here, and I'm going to be running in the command line, running commands, showing you how to navigate the command line itself. Who has used the command line before? Who uses PowerShell or the Windows command line? Okay, who uses Linux? All right, and then Mac OS? Okay, so Mac and Linux are going to be pretty much the same command line, a different shell, but same idea. Cool, so we'll be using that a lot this semester. Has anybody used SSH to typically log into Eustace? Okay, and does anybody use MOBA Xterm? All right, so for this course, I am going to stipulate that you have to use SSH. You cannot use MOBA Xterm. And the reason for that is because MOBA Xterm hides some details from you in logging in. This is all listed online too, so you don't have to write any notes on this, but you will need to use SSH from the command line to log into Eustace for completing the course assignments. And there's a ton of stuff you can do in the command line, so I guess just to peel back the curtain a little bit, this whole presentation is actually in the terminal. This is not a PDF file. So I have a software that I've installed called Presenterm. It lets me actually convert a markdown file into a presentation and then open it in the terminal. I can then export that markdown file to HTML, and voila, I have a single file that exports both to a presentation for class and also the course notes on the course website. So a way of working smart, not hard. I don't have to create two separate documents and maintain them. Another example. You can have file browsers in the command line. So there's one called Ranger. So I have a whole file explorer here with image support and everything, all via the command line. There's also a web browser in the terminal. So I'll go to the course homepage here. I'll copy this in. And now I'm actually navigating the whole course homepage just from the terminal. So yeah, the terminal is pretty powerful. It's not just some limited, claustrophobic, confined environment that you're forced to program in. There's reasons why I want you to interact with it, just so you can kind of get an idea of what it's really good at. Now, you won't need to be using any of these tools that I just showed you throughout the semester. I just want to make you aware of all the different things you can do on the terminal. So again, version control. We're going to be looking a little bit at how version control actually works, but mostly we're just going to be using it for completing assignments. And for all the exercises and projects this semester, you're going to be using Git to upload them. You're not going to be interacting with web courses at all. They're just going to be logging into Eustace, using Git to stage, commit, push your files, and we'll be going over all of that in a future lecture. But just know that you'll be using Git a lot for all the project submissions throughout this course. Then learning how the file system works. So I think with the increasing advent of iPhones, smart devices, and such, which sort of hide the file abstraction from you, I think an increasing number of people are not really quite aware of what a file actually entails, how it's really just a mass of bytes that you can read and write from. And so to really make it clear, we're going to be going over this semester how files are organized in a Unix machine, what constitutes the file API, really just being able to read and write bytes to and from a file, and how files with directories create a hierarchical structure like you see here in this illustration. And you're going to be writing your own tools for navigating a file tree as well in C. That's going to be some of the projects. So we'll get into that later in the course. Okay. So the second goal of the course is not just learning to use system software, but also learning to develop it or build it ourselves. So file handling, like I said, we are going to be navigating through file systems, but also learning how to open files at a lower level than you might be used to in C. Has anyone used the fopen call in C before? Yeah? I'm assuming you've used it for projects in the past. You know it returns like a file handle, a file pointer. We're going to be using the open system call. We're going to be learning what a system call is. Just as an example, we're using open. That returns an integer, a file descriptor. We're going to be learning more about how to interact with that. Just a lot of the lower level mechanics of actually interacting with files on a Unix machine. So process management. So a process is just a running program. We're going to learn how processes are created. Spoilers, they form this hierarchical structure here, kind of like how files are created. And compilers. So the whole second half of the course is going to be devoted to writing our own compiler. So I'm really excited for this. In the past, we had the compiler be written in C++, but a lot of students were not familiar with C++, and so this past summer break, I rewrote the whole compiler in C. And it should be available, so it should be hopefully easier for us this semester to get started with it. I don't know, does anyone, I'm assuming you all have used GCC before, the C compiler. Has anyone used Clang, CLang? Yeah? So these are examples of C compilers. I guess, in case you're not aware, a compiler is a tool that translates the language that you write, the coding language you write, so for example C, into the machine code that is executable on your CPU. So this semester we're going to be looking at, in the second half of the course, how such a program actually works and how we can write our own program to achieve that purpose for a simple language that we're going to be developing. I also have some ulterior educational motives here, really just one, to make everyone a better programmer. So again, with this course, I think learning system software will make you a stronger programmer overall. And to sort of illustrate this concept, I'm going to be going over this fable, this tried and true classic, tortoise and the hare. So in this scenario, both the tortoise and the hare are given a programming project. I think you know how this is going to go. So let's start with the hare first. So when the instructor, me, gives everyone a project, what the hare would do, or the hare does, is immediately start with coding. They read the spec, they read the instructions, and translate it into code ASAP. They waste no time in writing tests, they just get straight to writing code. And this is kind of cool at first, it feels good, and they're able to finish writing the whole project before the tortoise can even write a single line of code. But then they go to actually run their code in the test cases we give you, and the hare notices that they fail some of the test cases. So they scramble and go back to fix the test cases that are broken, and they get them all working eventually, the broken ones, but now in fixing them, they've broken other test cases. And so now they have to go back and fix those. And now they're finally just scrambling, spending all the time until the project deadline to try and fix all the test cases. And when they finally upload all the test cases to the grading server, they are shocked to find out that they still don't get full credit because there are hidden test cases. And we'll be doing that this semester. We're only ever going to give you, for projects at least, half of all the test cases. The first half will be public, the second half will be private, but we will describe them to you in text. So what you should do, as you're going through this semester completing the projects, is use the public test cases and write your own test cases to test the private hidden functionality. Yeah?
And will all of these be checked by like an auto graded on usage?
Yes. Yep. So we have automatic grading scripts for all the projects. We have one of the graders, so I have 3 graders this semester and a TA. One of the graders will be downloading the projects as soon as the deadline has been reached, and they'll be running a script to automatically grade all your assignment submissions. So it is crucial that you follow the correct instructions carefully to upload your projects to the grading server. Once you do it once, it's pretty easy to do it correctly. You just have to follow the instructions carefully. All right, so let's go to the tortoise. The tortoise does not rush into programming. The tortoise reads the project description carefully and then goes to the bottom of the project page where we describe the test cases. Every project page at the bottom we describe the test cases. And the tortoise writes their own test cases for the hidden tests and tests their code as they implement it slowly on every single test. So they just implement the project one piece at a time and test it as they go along. And by the time they submit their project, the hare is still scrambling to fix broken test cases, and the tortoise is done early and gets full credit. So in the end, even though the tortoise was perhaps slower initially than the hare, because they were deliberate and cautious in how they were writing their code, they were able to actually finish sooner. So the moral of the story is to be the tortoise, of course. It feels really fun to just write a bunch of code. Maybe if you have like a late night and you're fueled by caffeine, you just want to write a ton of code all at once. And that feels really great, but what feels horrible is debugging the next day. So you don't want to do that. Go slow, delay your gratification, and implement things one piece at a time while testing along the way. And this sort of recapitulates what I just said. And one more piece of advice I'll mention here is to write your own tests and save them. So a common novice mistake when programming is to have a single test file that you keep using for all your tests. And then when you want to add a new feature, you just modify that one test file and then test that new feature and keep going. You should create separate files for each test and develop your own test suite along the way. That's something that a cautious and deliberate programmer would do. More experienced programmer would do. And then breaking the problem down into pieces, we'll talk about that more later. That should sound like a familiar strategy to you, divide and conquer. And you want to avoid being too clever when programming, so Brian Kernighan, another famous computer scientist. Does anyone know Brian Kernighan? One person? What is he known for?
Working on it, creating C.
So he didn't create C, but he did create
The manual. Well, he worked on the manual before.
the C programming language, the book called The C Programming Language, but he didn't write the C programming language. And he has this really great quote: "Everyone knows that debugging is twice as hard as writing a program in the first place. So if you're as clever as you can be when you write it, how will you ever debug it?" So that was the issue the hare had. The hare was trying to be clever and quick and wrote as much code as they could as fast as possible. And then when it came to debugging, it was impossible for them to debug the code because they were as clever as they could be. They kind of maxed out in their ability to write code when they were writing it initially, and now it's impossible for them to debug it. So write simple code, write almost stupid code. Don't worry about optimizing. Don't worry about making it as general as possible. Just get it working simply as possible, and then you can debug it more easily later on. So kind of leads into my next question here. What is a bug? So I'm going to ask a question to the audience. Can anyone tell me their definition of what a bug is? Yeah?
Code that works in unintended ways.
Unintended ways.
Or something
Okay.
that doesn't work as it's supposed to.
Doesn't work as it's supposed to. Okay. Any other definitions? Yeah.
A code that compiles but doesn't run the way you expected.
The way you expect it to. Okay, so that kind of leads me to my next slide. I've sort of laid a trap with this question. I'm going to argue that a bug is not that the program does something wrong. A bug is more so when a program does something you don't expect it to, so like you had said. A bug is really a gap between what the programmer thinks a program does and what the program actually does. So a good way to actually solve bugs or fix bugs is to create small test cases like we've been talking about this whole time. Divide and conquer. Divide the problem down into smaller parts. Create test cases to target those individual parts of your problem. That lets you more easily trace the bugs back to their relevant source code and then fix them. really you want to go step by step through this. It should be very methodical. You shouldn't use any of these like soft verbs to try and figure out what your program does. Hope, feel, guess, divine, reckon, whatever. So the overall goal when we're writing code is that we're given some specification, for instance, a project description, and you're trying to translate that into an implementation, into code. So this sounds easy, but it can be deceptively difficult to do, and this is why programming is sometimes, or usually, a very hard endeavor to do. Okay, so the hard way to write code is to write the whole program at once and then try to debug it. And if you do this, you end up in a situation like like this image here. You have a fly swatter, and you're just swatting all these flies. There's bugs everywhere, and you have a hard time finding them all and catching them. So yeah, think about debugging 3 if statements versus 10, and they're all nested. It's a lot harder if you just write 10 nested if statements and then try and fix them all at once. Yeah?
Well, what if, like, in order to debug something, you need code that hasn't been written yet, like a piece of code that relies on that?
It's kind of hard to see without a concrete example, but you'd probably want to divide your code up into individual components so you don't need to have them all coupled together to where the existence of one piece of software or one piece of your implementation relies on the existence of another in order for you to be able to test it.
So, like, modular?
Yeah, modular design. This is what unit testing is for. Yeah. Which kind of leads me to my next point here. The lazy, easier way, you want to be like this frog, just lazily catching these bugs. You just write a piece of code, have the test case ready, and then test that individual piece as you go on. And the overall approach here is just divide and conquer. So you should be familiar with this from CS1, this idea of divide and conquer. We can apply it to writing code, not just to algorithms. And now what I want to do is illustrate this with a drawing. So throughout this course, I'm going to be using this app, Excalidraw, to draw things, and I'll be posting these board notes online as well after the lecture. So let's say we have some specification here. This is what we want our program to do. And what we need to do as part of our job or as a student is translate this into an implementation. I'm going to put this over to the side. So the novice and really not great way to write code is to just implement the whole spec at once. Let me see if I can make that a little bit bigger. I guess not. Oh well. You implement the whole spec at once. I'll be a little messy here. And you have the whole program written. That's cool. But the problem with that is that now you might have bugs anywhere in this spec or in this implementation. So you have to navigate this entire search space in order to find where these really messy, ugly-looking bugs are. The better approach, I'm going to copy this and paste it here. Actually, let me leave that there. And I'm going to be hoping you practice doing this semester, is to instead divide the implementation up into components. So again, divide and conquer. And we have tests for testing each individual piece of the overall implementation. So now, if you go to implement this, I'll draw this again. We implement one piece, and we run our unit tests. We find no bugs. Implement another piece. We run our tests. We find maybe a bug or two. Now it's easier to find those bugs because the search space is narrower. That's the idea illustrated for you of divide and conquer when writing code. Just make your work as small as possible for you when debugging. And I'll just fill in the rest of this for the diagram's completeness. Maybe add a little bug here. Okay, so any questions? Yeah.
Might be a stupid question, but is that the same thing as object-oriented programming? Or is that like
Object-oriented programming is a paradigm. It's not a stupid question. That's a paradigm in which we encapsulate data and attach methods to each piece of this data. Yeah, this isn't an OOP class. I'm really not going to be using any OOP at all this semester, but yeah. Yeah.
So I guess, like, you probably already said, so like the goal is to make where, like, you code each parts of the program separately, but all, like, as a whole, they're able to come together to make the whole program.
Yes.
So program them separately, debug them separately, which in turn makes the process easier.
Yes. You don't have to, but if you do that, that's software engineering. If you write your code and architect it in a way such that as you write it, you reduce the likelihood that you will have bugs later on, or at least make it easier to catch bugs when you do have bugs. That's what good software engineering is. Mm-hmm. Okay, let's go back to the slides now. Yeah, just some general advice here. I won't spend too much time on this. There's a paper you can read here, more information. And what I'm going to end these slides on are Larry Wall, the Perl programming language developer. I don't know how many of you have heard of Perl. It was a pretty popular programming language, probably like over a decade ago. Fun fact, the Perl programming language source code, at the top of many of the files, in the comments, they have quotes from Lord of the Rings hidden throughout it. So, yeah. Anyway, so this guy, he has 3 virtues of a great programmer that he's listed. And they're all really not virtues. They're things you would typically associate with not being a virtue. The first is laziness. And let me see here. I have notes on the exact definition he gives. This is the quality that makes you go to great effort to reduce overall energy expenditure. Let me see if this is shown on the screen. There we go. It makes you write labor-saving programs that other people find useful and document what you wrote, so you don't have to answer so many questions about it. So again, you want to be lazy so you don't have to do as much work, and you also want to write good documentation, because again, you're lazy and you don't want to have to answer questions a billion times. That's why this course, part of the reason why the course notes are hopefully very complete, and I have lots of different resources listed on the course website, and try to make it very easy for you all to access. The next virtue here is impatience. So the anger you feel when a computer is being lazy, this makes you write programs that don't just react to your needs, but actually anticipate them, or at least pretend to. And in the very next lecture, we're going to see some examples of programs that seem to anticipate your needs. Has anyone used tab completion on the command line? All right, if anyone has used that already, they know what I'm talking about. That seems to anticipate your needs. In the next lecture, we'll see that concretely. I'll give you lots of examples of that. And finally, hubris. Does anyone know this word, hubris? Can anyone define it for me? Or tell me what it means? Yeah?
Excessive pride.
Excessive pride. And like I said earlier, I like to read. In literature, it often has a connotation of you having excessive pride against greater beings or forces, and you're about to get smited for it. So here, he's using this term to mean excessive pride. The quality that makes you write and maintain programs that other people won't want to say bad things about. So you're so proud of yourself that you really don't want anyone to tarnish your name, so you write programs that are as perfect and good as possible. So this is really like tongue-in-cheek, not meant to be taken super seriously, but there is some wisdom in this, and that you should try and follow these 3 tenets, or at least the core ideas behind them when writing code. Okay, close this. Let's go back to the laptop now. All right, so any questions on the slides before we go over the syllabus? That'll be the next half of this lecture. Okay, so I'm going to go to this page here. Actually, I'll go to web courses. So what you'll do to get to the course homepage, how many of you have seen it already? Okay, cool. So we'll go to web courses. The homepage of the web courses page has a link to the official course homepage. So I recommend bookmarking this page. This is what we're going to be using for the course. The reason why we use this custom website and not web courses is because this is much faster. Believe me, you can navigate between the links and it just like loads right away. You don't have to worry about anything loading. There's no dynamic content. It's really fast. Okay. So on the left-hand side here of each page, there'll be a table of contents that you can look at. All the general course information is listed here. Office hours begin next week. So we have office hours on Monday, Wednesday, Friday with Sinan Hasanov. He's the TA for this course. So Sinan's a friend of mine. He's another student of Dr. Gazzillo. So he's like a cybersecurity expert. So if you have any questions about cybersecurity or you're interested in doing research getting started with research with the Linux kernel and testing it, you might want to reach out to him or come see him during office hours. His dates and times will be listed here. And then I have office hours starting next week before and immediately after lecture in the same room as Sinan, Health Science 2, room 244. So yeah, before and after lecture. There'll be labs on Fridays. There's 3 labs, they're back-to-back. You can attend whichever lab you want. I do not grade lab attendance. I recommend attending them if you want extra project review or supplemental information about the course, things related to the course, or you want review for the homework assignments or for the midterm or final exams. Here's the whole course schedule. I recommend maybe saving a bookmark to this specific heading if you're going to save a bookmark to this page. So we have all the course notes listed here. So the slides I just showed you, let me zoom out a little bit so that this table of contents doesn't interfere with the page. Okay, the slides I just showed you are fully listed here. All the content is listed here and the speaker notes, they're all listed here. I've also included fun facts on the right-hand side, which I do not include in the lecture. They're supplemental, they're not relevant to you getting a good grade in the course, they're not going to be tested for, but just some information on the right-hand side sometimes that you'll see. For every lecture, I'll be posting a video recording of the lecture and the board drawings if I draw anything that day. Also, there'll be recommended readings. You should complete these readings. If you do complete them, you will definitely get an A in the course. I can't put it any simpler than that. So for this first reading, we'll have instructions on how to connect to Eustace. I recommend you follow this. It'll be helpful in completing the first homework assignment, in which all you have to do is just SSH into Eustace and send me a screenshot of you having done that on web courses. So the homework will be submitted via web courses, but the projects and exercises will be submitted via Git. Yeah?
Is there any books that you recommend purchasing so we can complete all the reading?
You don't have to purchase anything. I'm going to get to that. Good question. You'll see links here to LPI and 21st. Those are acronyms for the textbooks in the course. There are links to access these books for free online. Just please follow the instructions listed here. If you are going to download the textbooks, let's see. Yeah. Download individual chapters. Do not download the whole book and do not choose the read online option because we have one account that we share for the whole class, basically. So if you choose the read online option, you might lock other people out of using the book. So just choose, there's literally a screenshot with text and it's circled and everything. So just follow the instructions. Just download individual chapters and read those. That's all you need. And it's all free. Yeah?
For the recommended readings, is it better to read them before or after the lecture?
I would say after is probably fine. You could read it before. The lecture will just be a review for you. They're both the same content, so whatever order is easier for you. Yeah. If you read it before, you can probably ask more insightful questions during the lecture. Yeah. But it might be easier to read it if you read it after because you'll already have reviewed the material during lecture. So I don't know, pros and cons of each. Okay, the next recommended readings for tonight are going to be Vim or Emacs. You can read either one of these. So Vim and Emacs are terminal-based text editors. Emacs they both have GUIs you can use, but most people use them via the terminal. I prefer Vim, so I'll be using Vim a lot this semester. I don't know, I guess, who uses VS Code as your editor? Okay, most people, I figured. Who uses Vim? Okay, who uses Emacs? No one? Good. No, I don't have any hate towards Emacs, so that's fine. Dr. Gazzola likes Emacs, my advisor, so yeah, I kind of mess with him sometimes about it. All right. Anything else? Any other editors anybody else uses? None of the ones that we just mentioned? Okay, C-Line or?
Sublime text.
Sublime, okay. C-Line, okay. So I'll be using Vim a lot. The reason why I like to use Vim is because it's on the terminal, so more experience using system software. And Vim is everywhere on Linux machines. Most Linux machines have Vim pre-installed. Most Linux machines do not have Emacs or CLion or Sublime Text or VS Code pre-installed. So if you know how to use Vim, you can just log on to a remote machine and get started right away. Yeah?
What about Nano?
They'll have Nano, but Nano's, as you'll see, you can go really fast in Vim in ways that you cannot go fast in Nano. So I'll be trying to use baseline Vim for most of the semester, not really adding any plugins or extensions, so what you see is what you'll see on your machine. I might change the theme and colors a little bit, but I'm going to be going pretty fast sometimes when I'm writing code with Vim just to show you what is possible with these more traditional command line tools, and that they're not actually very slow or weak or unnecessarily abstruse as you might think. So I recommend either learning how to use Vim or Emacs in the beginning in this first reading. Yeah?
I've heard for using Vim, you have to learn the different key bindings, like for copy paste and moving up and down. Like, how does that work?
So Vim is a modal editor. I won't go into the details too much, but basically, you're not when you open VS Code, you're always in insert mode. Basically, you're always editing text. In Vim, if you press Escape, you're no longer editing text. You're moving around your text file, and then you can press another button to yank or copy text, and another button to paste text. And there are settings you can configure in Vim to yank to your system clipboard, so you can get the same effect as if you would press Control-C in VS Code. Yeah. But if you go through the Vim tutor, it's an interactive tutorial. You can learn how to use all this. So, yeah. So as the semester goes on, oh yeah, question?
For those of us that haven't used Git before, will there also be instructions for that?
Will be a whole lecture on Git, right here, version control. In fact, it's all publicly available right now. So all the lectures, you can read them online before we actually have the lecture. They're all available. But know that I might update the lectures as the semester goes on before I actually give the lecture, maybe afterwards in response to student feedback. Yeah?
What language will be considered assignments?
It will be mostly C. You will have to know how to run some commands using bash. We will be learning bash commands for navigating the command line, creating files, manipulating files, printing out their contents. But when we're actually writing our own system software, we'll be running it all in C. And the reason for that is because Intro to C was a prereq for this course, and CS1 usually is taught using C as well. So we're trying to build off what you have hopefully learned by this point in the curriculum. So again, as the semester goes on, we'll be adding more information to this table. The homework will be posted here. Exercises and projects will be made available. I have the permissions set to disallow, prohibit from reading for now, but I have a script that automatically updates them when it's time for these projects to be released. So on September 1st, the first exercise will be made available for you. And the deadlines are all listed here on the right for the exercises and projects. So try to keep it all organized in one big table. Okay, so for the actual grading breakdown of this course, attendance is graded. I'll say that. Again, attendance is graded. I will not be grading attendance the first week. It's only worth 4 points, so if you think you know the course really well, you don't want to attend a lecture, it will not prevent you from getting an A. But it's to encourage you, to incentivize you to show up. And if you do show up to at least 75% of the lectures, i.e. you get 3 out of 4 points on attendance, I will give you 2 extra credit points. So you could get 3 points on attendance, get the 2 extra credit points, and get 5 out of 4 on attendance. Lab attendance is not graded, it's just attendance for here. And the way we take attendance is through UCF here, which I think there is an app for UCF here, correct? Yeah, so you might want to download that app if you don't already have it. And then we'll be starting next week with scanning the QR code that appears on the screen for taking attendance. There'll also be a physical attendance sheet for those of you who don't have a device that can scan the QR code, but please try to use the QR code if you can. It's much faster for me to if you just scan it and then it's automatically in the system. And I don't take the attendance at the same time every day. It's typically somewhere in the middle of the lecture just to encourage you to stay and not just scan and then leave, or come in at the very end and then leave. There are 2 exercises in this course. Each exercise is worth 4 points. Exercises are due a week from when they're given, or no, 1 week from when they're assigned. No, sorry. 1, 2, 3, about a week and a half, whenever the due dates are listed here. After they are due, you have 1 week to submit a regrade request. You can re-upload your code for the exercise, and if you your code, after you re-upload your code and request a regrade request to the grader for the course who handles the regrades, you can get only a 1 point penalty out of the 4 points for the exercise. So you can still get 3 out of 4 points. Midterm is worth 8 points, final is worth 12. For the midterm and final, you'll be allowed to take lots of notes with you. 8 pages double-sided for the midterm, 12 pages double-sided for the final. I'll be reminding you all about that again when it gets closer to the exam. Homework, there's 20 of them, actually 24 of them. Each one is worth 1 point, but 4 of them are dropped. So your 4 missed homeworks are, if you miss up to 4 homeworks, they're dropped. Only 20 of them count towards your final grade. And now finally, projects, they're the most important part of the course. You can see they constitute by far the greatest, that category is a single greatest category for your points for the course. This is a project-based course. So we'll be giving you lots of projects, 6 of them in addition to the 2 exercises. These will start off somewhat easy, but they're going to get harder very quickly. And they will be difficult in different ways. So I recommend starting early when you get assigned a project and do not wait till the last minute to complete the project, especially since Eustace is sometimes not super reliable, there might be connection issues, and you might not be able to upload your code on time. And if that happens, I cannot grant you an extension if there's a connection issue because these projects have been assigned now at the very beginning of the semester. You've known about their due dates well in advance. I can't give you an extension for these projects if there was a connection issue. But to make it easier for you, every project you can resubmit so let's say you submit a project and only get partial points, they're worth 8 points. Let's say you only get 4 out of 8 points, you failed many of the test cases. You are allowed to resubmit every project until December 12th. And when you do that, you can get up to 7 out of 8 points. Only a 1 point deduction, not 7 out of 8 points. You get a 1 point penalty, and with some projects there's even extra credit, so you can get up to 2 points of extra credit. So if you were to get 7 out of 8 points and then do all the extra credit, you would get 9 out of 8 points on that project, even though you submitted it late. So we try to be very lenient with the project grading in this semester to encourage you, to reward you and encourage you to do well, rather than penalizing you for maybe missing a deadline. If you want to regrade, request a regrade, there's steps here on how to do that. What you would do is re-upload your project via Git. We'll explain how to use Git later in the semester. And then just copy and paste this email, fill in the parts and tags here with your information, and send this to the grader who's responsible for grading, Marco Morris. And Marco will handle the regrade for you. Please do not spam Marco with requests for regrades. They often get flooded with them, especially towards the end of the semester when students all scramble to submit by the 12/12 deadline. So please submit your requests in a timely manner and just give them at least 3 days before you submit a reminder or ask them again about the status of your grade. And note that this is the deadline for requesting a regrade. So if you submit a new version of your project on 12/12, but don't make the request for a regrade until 12/13, we will not be processing that regrade request. Because we need time, final grades are due I think on 12/15, so we need time to actually get all those grades into the gradebook. One more thing to mention, homework assignments are due the minute before the following lecture. So this trips up a lot of people. I do it to give you as much time as possible because I review all the homework in class as soon as the lecture starts. This homework assignment, homework 1, is an exception because it's the academic engagement activity. It has to be due, I think, available for at least a week or something. It's a little different, but for homework 2, just know that it will be due at 11:59 a.m. on September 1st. So it's not PM, it's AM because the class starts at 12 PM. I make homework due at 11:59 AM before the next lecture. So, yeah, just keep those deadlines in mind. And this is all in web courses too. So if you just read web courses carefully, you'll see all this is listed there. I try to keep like no surprises with the course. All the details are listed here. Okay, and if you have questions about project grading, please read this FAQ first. I'll be adding to it as the semester goes on. If you do not read this FAQ and you send me a question that its answer is in this FAQ, I'm just going to send you an email telling you to read it. So please read the friendly manual before you email me. The exams will be in person, so you'll actually come physically to the same lecture hall. You will bring your laptop with you, and you don't have to use a lockdown browser. In fact, do not use a lockdown browser. Just come here physically, take out your laptop, you'll take the exam on web courses. We'll have 4 proctors walking around, making sure everyone is being honest for taking the exam. And it was completed on web courses in this room. Here's the grading schema for the semester. You will need a laptop to complete the assignments. I will be bringing paper copies of the exams on exam day, but I will not be bringing one for every student. I will be bringing a limited number of them. So please try to bring a laptop on the exam day. I think UCF recently discontinued its LibTech service, which offered rental laptops, but I think they're trying to start a new similar service. I don't know exactly what's going on, but I'll let you know as the semester goes on if there's any updates on that. I have a friend who works at LibTech who can give me some updates on that. So, textbooks, free, you can download them using the instructions. The page looks like this. You'll just click on download PDF for the individual chapter you want to read, and then you can read that chapter. You have a limited number of pages for download, but the number of pages we ask you to download for the semester is well within that page limit. So you should be fine. All right, and these are just policy statements at the bottom. And I have to mention this one, AI, please don't use AI. I can't enforce it that you didn't use AI in your projects, but please don't. And on the exams, if you use AI, you will get a 0. I've had people in the past try to sneak by me and use AI during an exam, and I caught them, and it's just not fun. I guess just a reminder, I can see when you tap out during web courses exam. So if you think you're going to like change windows and use like ChatGPT to help you on the exam, don't do it. I can see that. So yeah, just it's easier for both you and I if you don't. Okay. All right, so that's the syllabus. Any questions? Yeah.
Could you reiterate one more time how the exams work?
Yeah, so for the exams, you'll be bringing your laptop, coming physically to the lecture, and the exam will be posted on web courses as an exam on web courses. You will take the exam on web courses here, and there'll be proctors walking around making sure everyone's not cheating or anything. And when you're done, you just submit it via web courses and you're free to go. But you'll have to, asterisk, you will have to show me your ID before you leave. On exam days, I take attendance manually to make sure everyone is taking their own exam and does not try to take it from home. Yeah, question?
Will the exams be mostly question-based, or will they also have like programming?
The breakdown is already available for all the exams, so you can click on midterm review right here. I may not use this exact question breakdown, but we probably will be using something similar this semester. So for last semester, for instance, the midterm had 16 multiple choice questions, 3 short answer, and 1 long response. Short answer was like 1 line of code responses usually. Long answer is going to be a complete program, often, yeah. Oops. Okay, if there's no more questions, then you all are free to go. If you have any questions, please come to me now.